morning. It's Thursday, March 26th. Here's your notes for today. So we're going to be talking about the natural log, and you have seen the natural log come up in your homework before, and up until now, I've told you to just kind of ignore it. So today we're actually going to talk about what that means. The natural log is a log that has a base e, Euler's constant. The same e that you would see when we would do those compound continuously problems, PERT, so same e, Euler's constant. But instead of writing log base e of an argument, logarithms with base e have their own name, natural log. Okay, so for example, if you were to see the natural log of 4, it's the same as saying log base e of 4 equals x. And we know we can rewrite any of these logarithm problems as exponential problems by taking the base raised to the power equals the argument. Okay, you also have a button in your calculator for the natural log. So on the left-hand side, right underneath the common log, you see the natural log, and it's no coincidence that printed just above that is e to the x power. So the natural log and e are inverse operations of each other. They actually undo each other, and you're going to see what I mean in a second. So if you are given e to the x minus 2 equals 12, you can use the natural log to solve exponential equations as long as the base is e. When the base is e, you use natural log. If it's not e, you don't use the natural log. So in this case, we've got a base e, so I'm going to take the natural log of both sides. And then my rules of exponents still, or rules of logarithms, excuse me, still apply here. So I can pull that exponent out front, and it becomes the coefficient of my problem, 12, sorry. So we've got x minus 2 equals the natural log of e equals the natural log of 12. So the natural log of e, those two things are actually inverse operations of each other. So if we were to take the natural log of e, it would be equal to 1. They undo one another. So natural log of e is equivalent to 1. So this equation becomes x minus 2 times 1, which is x minus 2, equals the natural log of 12. And then to solve for x, we add 2 to both sides. Okay, so I can go ahead and punch that into my calculator here. Natural log of 12, close your parentheses, and then add 2, and I get 4.48. Final answer. Okay, example 2. Oops, I need to change my pen here. We're given 4 times e to the 2x power plus 2 equals 16. Okay, so we're given a base e. We know that we're going to have to use the natural log to solve this problem, but order of operations still applies. I'm not allowed to touch this exponent until I first deal with my addition and subtraction, so I'm going to subtract 2 from both sides. And then I still have to divide by 4. I have that coefficient up front I have to deal with. And I'm just going to reduce that. No, what am I doing? I'm sorry, I'm very tired today. I didn't sleep very well last night. Let's just go ahead and use the decimal. Whoops. 3.5, sorry. Okay, now that we're down to just the base and the exponent, we can take the natural log on both sides. Okay, so I can pull that 2x out front times the natural log of e equals the natural log of 3.5. The natural log of e is equivalent to 1. Those things cancel each other out. So that gives us x equals the natural log of 3.5, divide both sides by 2. Okay, so I can plug that into my calculator here. Natural log of 3.5, close that, divide by 2, x equals 0.63, I'm going to round. Okay. Okay, so just like you use the natural log to solve e problems, you use e to solve natural log problems. So let me just show you one of those. If you're given the natural log of 3x equals 5. We know that natural log uses base e, so I'm going to go ahead and rewrite this as base e raised to the 5th power equals 3x. And then we can solve for x by dividing both sides by 3. So x is going to be e to the 5th power over 3. I'm going to punch that into my calculator. Divided by 3 is 49.5. Okay. All right, so we're almost done here. I just want to show you an additional application of the natural log. You can use natural log problems to solve compound interest problems. So I went ahead and wrote the problem ahead of time to save some time on the tape here. It says you deposit $1,000 into a savings account that compounds continuously. So there's that clue word telling us which compound interest formula we're going to have to use. The account pays 5% interest. How long will it take you to double your deposit? So because we're using the continuously compounded equation or formula, PERT, we can plug in what we know. They're asking us to double our investment. So if we're depositing $1,000, doubling that would be $2,000. E is a constant. The rate is given to us 0.05, not 0.5, be careful, 0.05. And what we're actually solving for is t. It's asking how long. We're figuring out how many years does it take for this to happen. Okay, so we're given a base e here, which means that we're going to have to use the natural log to solve for t. So I'm going to divide both sides by 1,000, order of operations. I've got 2 equals e to the 0.05 times t. I'm going to take the natural log on both sides to give me, let me just flip this over, make it a little easier to read, 0.05 t natural log of e. So I wrote this on the left side of the equation equals the natural log of 2, so that when I solve for t, it'll be on the left side. We know the natural log of e is 1. So t is going to be the natural log of 2 divided by 0.05, the interest rate. I can use my calculator to solve that. Natural log of 2 divided by 0.05 is 13.86 years. I'm around that, 13.9 years. So a long time to double your money. Okay. So you only use the natural log when you're given base e, and you're only using the base e problem when you see that word continuously pop up. If you're given a compound interest problem that doesn't have continuously, you're not going to need e to solve it, or the natural log. You're just going to use the other log, the common log. This one says you deposit $4,000 into a savings account that pays 6% interest compounded quarterly. So there's our clue. How long will it take for your balance to reach $10,000? Okay, so because it's compounded quarterly, we're using the standard compound interest formula, which is A of t equals p times 1 plus r over n to the nt power. They're asking us how long it takes, so we're solving for t, how many years, for it to reach $10,000. So $10,000 is our new balance. Our principal is $4,000. Our interest rate is 0.06. And our n, the number of times it's compounded, is quarterly. So that's 4 times raised to the 4t power. Okay, so first thing I'm going to do is just simplify what's in that parentheses here. And I can just use my calculator for that. 1 plus 0.06 divided by 4, oops, 1.015. So your calculator understands order of operations here. It knows to do the division first and then to add 1. So 1.015 raised to the 4t power. Next, I have to follow order of operations, so I'm going to divide 4,000 on both sides. Okay, And now that I'm down to working with the exponent, I don't need the natural log in this case. I'm not working with base e. I'm going to use the common log instead. Common log, so we can, I'm going to switch the order of my equation again, just so that I'm solving for t on the left-hand side. Okay, so I took 4t from the exponent, put it out front. Log 1.015 equals log 2.5. Okay, and on both sides here, I can divide by 4 times the log of 1.015. So I'm going to take log of 2.5, close my parentheses, divided by, in parentheses, 4 times the log of 1.015. 15.4 years. Okay, so if I deposit $4,000 into a savings account that pays this much interest compounded quarterly, it'll take me 15 and a half some years for me to reach a balance of $10,000. Okay, your homework assignment is just practice problems from what we did today. I actually don't have the paper in front of me, so I will post it on the classroom assignment post. Good luck.